Thank you so much for that introduction. Yeah, that's interesting that you bring up my PhD work, which was back in the 1980s, because I feel we've come full circle when we come back to learning analytics. And in fact, today I'm going to talk about a project that we have about adaptive learning in schools. And originally from Canada, and when I moved to Norway around 1991, nobody was interested in artificial intelligence at all. So I moved into other areas and worked. And now 30 years later, we have a national center for learning analytics where adaptive learning is one of the big areas. So it's a bit interesting for me. I wanted to show you where I am. I'm sitting on the west coast of Norway. It's actually about 23, 24 degrees here today, sunny and beautiful. And if other people know, maybe you know about Norway, and in the western, in Bergen, we have a lot of rain, but today it's a very nice day. These are some other pictures. The university's in the center of the main downtown peninsula, and I welcome everybody to come and visit us in Bergen. And I took this picture on a Friday night about 11:30 at night, about 2 weeks ago. So you can see it's very daylight here still at this point of time. We're into the summer hours. And so it's nice and bright most of the day. Okay, so today I'm going to give an overview about what learning analytics is. Many of you probably know, but maybe some of you don't. What data we use in learning analytics, and I'll show you some examples of different kinds of learning analytics, and then I'll talk about this particular project that we had about adaptive learning in schools, and then some reflections over what I've learned working on this project the last 3 years. So if we go back to the beginning and look at what learning analytics is, the very first definition that was used in 2011 at the LAC, the conference in the field, is that learning analytics is the measurement, collection, analysis, and reporting of data about learners and their contexts for purposes of understanding and optimizing learning and the environments in which it occurs. And here I've highlighted learners and their contexts, learning and environments, because it's not just about the individual learner and their behaviors, it's also things about the environment in which they're learning. And we want to improve, and I'm not so keen about the optimizing term here, but we want to improve learning and we want to improve the environments in which it occurs. So when we talk about learning, we can mean many things. We can take right from the psychological understanding of what learning is as a phenomena, how it works in the brain, the neuroscience of it, etc. We can also talk about learner behavior, how learners behave in learning environments. We can talk about learning outcomes, what's coming out the other end of a learning process, for instance, or we can talk about the learning process in itself, what's going on over time. We can also talk about self-regulation, about motivation, about engagement. So in learning analytics, we find projects looking at all of these different sorts of things because it's really hard to actually find out what learning is. And we really look at these other kinds of aspects in the majority of our cases. We can also look at teaching because it is also about the teaching processes. We can talk about teacher or instructor behavior. We can talk about learning design. We can talk about curriculum design, professional development of, for example, the teachers or the university instructors and how they develop themselves using student data, for instance. And we can also talk about educational practice or educational spaces, which maybe takes us up to things like even rooms, how we design rooms for learning, etc., and all the way up to sort of academic analytics where we could look at the practices within schools or within universities, etc. So there's a wide variety of things that learning analytics can have to do with. And there's many stakeholders for the learning analytics that we carry out. We can have the learners and the teachers. We can have tutors or study leaders. We could have school leaders, policymakers, educational technology developers, so those that make the tools that we use for learning, and of course for researchers. And I think it's always a good idea to remember who you're directing your learning analytics at and what it's doing. This is a visualization of ISO's definition of what learning analytics is. And it starts usually with a learning activity of some sort. You collect data, you store and process the data, you analyze it, you visualize, and then there's some kind of feedback action. And each of these boxes in itself could be considered a research area within learning analytics about how do we collect the data? What kind of data do we collect? How do we store and process it? Things about interoperability and sharing data between systems. Analysis, what are all the different methods that we can use in learning analytics, from statistics to neural nets to machine learning, etc. And visualization, how do we make good visualizations for people to understand what the analysis of the data we want to show. And very important, is there some kind of feedback action? And sometime we could go right from the analysis and give feedback action. Some of Pilardo's work, for example, on giving good feedback to students. And we don't necessarily have to have visualizations. In the visualizations, we very often have these kinds of dashboards, either teacher or student facing, but I'll come back to those in a moment. Another way to look at learning analytics is Baranowski and Feng and Mean's really nice report on enhancing teaching and learning through educational data mining and learning analytics from 2012, but it's still very relevant if you want a nice basic report on learning analytics, is that it can enable adaptive learning. And I'm showing this one because I'm going to talk a bit about adaptive learning, our adaptive learning project. And here there's some kind of learning system with which a student interacts. And you have different kinds of data in this system. You have outside the system, you'll usually have some kind of student information system that can have like your demographic data and things like that. And then inside the system, you'll be building some kind of learner data model of some sort where you have the student learning data about what they're doing in this particular learning system. And then you'll have your either some kind of predictive model or adaptive engine or things that generate the next thing that a student should do or make decisions about whether they know something or don't know and what should they do next, etc. A third way to think about learning analytics is this from an architecture perspective. And this is from JISC, which is in England, which is responsible for higher education and the IT systems there. And they have been very early out in building these kinds of architecture constellations about how to implement learning analytics on an institutional level. Here you would be thinking about. So at some layer, you have your data collection layer where you're collecting data from student records, or they could be some kind of survey data to a student or their virtual learning environment or their learning management system from their use of the library, etc. So you have some layer of collecting data, you have some middle layer of storage and ways to analyze it. So maybe you have a learner record store, some kind of data hub, for example, and you need to integrate that data in some way. So whether that's done manually or by algorithms is up in the air. And then you need some kind of analysis of it, and then you some kind of analytics unit, and then you can put the data out as presentations or actions, alert systems, or giving feedback to a student through an app or a program they're using, dashboards for staff or for students as well. We have dashboards, etc. So there's a way to think about it. How do we actually implement that? I'm going to talk a little bit about that when I show you our project as well. And then some example uses. Generally, you can say that in learning analytics, we're looking for patterns, we're making predictions, or giving recommendations. So in patterns, we could look insight in things like insights into trends. There's some examples of identifying, difficult concepts when you're learning something, or finding out why people are failing a particular course, or finding out that they are failing a particular course at university. You can look for engagement or study patterns, interactions, networks. If you've got people working in discussion groups, for instance, you can look for patterns of networks, of who's talking to who, etc., what topics are going on, and things like that. Things that come from, usually a lot of that work is done in the field of computer-supported collaborative learning. And then you can look for learning trajectories, or you can determine learning strategies of students, etc. So you're looking for these kinds of patterns in the data. We can do predictions. We can predict things like dropouts or what successful students are doing, and we can look for early alert systems where you're could flag some students that are on their way to failing something and do some kind of interventions based on those predictions, trying to keep students engaged in learning or involved in courses, not dropping out, etc. And for recommendations, there's many different kinds. These are just some examples. You can have these adaptive systems that are adapting the content or feedback to students. This personalized feedback. You can recommend pedagogical resources or different activities. You could even identify courses or that students might like to take, or you could recommend some curriculum redesign. So again, there's a plethora of different kinds of things that learning analytics can be used for. As a research field, this is my take on the field. I think that it draws on several research fields: artificial intelligence in education, intelligent tutoring systems, which is from the late 1970s and 80s, educational data mining, which came around the end of the 80s, 1990s, the learning sciences from the early 2000s, and then the big data and business analytics. So you'll see traces of things from all of these fields in learning analytics. And I always say to my students or to people I talk to, sometimes you can look back at the older research in artificial intelligence in education or educational data mining, and you'll find some of the things people are thinking about doing now back in that work. The AI in education work is a multitude of really good research on how to give feedback and timing of feedback and all sorts of things that I think people can look back and learn from. And as a research field, we have a Society for Learning Analytics. So it's SOLAR, the Society for Learning Analytics Research. We have a conference, the Learning Analytics and Knowledge Conference. The first one was in 2011. And they also arrange many different events. One of them is the Learning Analytics Summer Institutes, where the first one was arranged at Stanford in 2013, and they tend to be for about 5 days. They have had them in Canada, in Vancouver, and in several different places in the States. And it's a really nice place to go if you want to go and learn about new techniques, to try out some of the analytics packages that you can use, etc. So it's worthwhile to go to if you want an intense week of taking 2 different tutorials and some workshops. And we have local learning analytics summer institutes. There was one in Spain last week. I gave a talk similar to this one, a little bit different, but similar. We have the Nordic Lassie. We're having that in August because of the pandemic. We're actually just going to have 1 day online and then have a new session next spring in Stockholm. We started that series in 2017, and then Lassie German has had a couple of sessions. So if you're in Europe, you can maybe find some information around those things. In 2014, the Journal of Learning Analytics came to be, and that starts to show that a field is starting to solidify. And for those Europeans, we have a new SIG or a special interest group for Learning Analytics Community Europe, which we're just getting the website up and going, and we will build on the first European project on learning analytics, which is called the LACE project. Okay, so now let's move on. We know the basics of what learning analytics, what data do we use in learning analytics? Because it's very, very dependent upon what kind of data we use. And if you look at traditional educational research over the last 100 years, you'll see this kind of data: student information data about the school they're going to, what their programs they're enrolled in, what grade they're in, etc., what marks they're getting. You get teacher-produced information like observations they make on their students or assignments, the rubrics they use to be able to give feedback to students, lesson plans, student-produced data such like homework or learning outputs, self-reflection notes or peer feedback, assessment and testing, of course. We've got tests and quizzes, exams. You've got behavior data like attendance, or are they participating in class or not? And then the general demographics data, age, gender, special needs, etc. All of that kind of data can be used in learning analytics as well. But in addition, we start to see other kinds of data as well. For example, different kinds of research instruments. Of course, we use those in traditional education research too. But we have surveys and questionnaires. Pre and post tests was very, to show that an intervention worked. Interviews where you might take up audio or observations or videos of things going on, sort of more ethnographic type studies, or focus group interviews, etc. But now we also have things like social media, people's participation in Twitter, Discord, or Slack, Facebook, blogs, YouTube. And then we have the learning environment where we have the digital tools and the data from the digital tools. And when learning moved to computers, we've had this data, this kind of log data for a long time, but now we have things like location data. We can have information about platforms or tools either clickstream activity data, which is this old log trace data that can give us information about assessments or interactions, about feedback, about content people are learning, about their participation in discussion groups, etc. So it tends to be this very large event-based data files. And then we have this new field where we are starting to get a lot of multimodal data. Well, we've had video and audio data, and we've had location data. Now we can get gaze from eye tracking data, from gesturing, facial recognition, movement data around rooms, EEG data even, galvanic skin sensors. My university, there are some people even using fMRI machines, etc., to use that kind of data from these kinds. And that area is a subfield itself called multimodal learning analytics. So if you're interested in all these many different kinds of data together, you can look at literature on multimodal learning analytics. And then the other thing, there's even studies, I've seen studies doing air quality to find out, is the air quality that goes down? Do people pay attention less in classrooms, for instance, sleep quality, exercise, health and wellness? So starting to bring in a little bit of health data, combining that with educational data. So you'll see, again, studies on all these different kinds of data. Here's just some examples of some of the newest, like the Tobii glasses. They're getting, having these much more detailed data that we can get from that. You can wear rings now that you can use to just flip your finger around and make it do different things for you on the screen. We've got the Aura Ring, which measures sleep and different aspects and sends that data to your app. Different kinds of nice facial recognition systems, etc. And then there's new things like wireless FNIRS. So that's that can measure EEG signals when you're not laying down still, but can move around, etc. And there's all sorts of these new kinds of things coming up, but we need to figure out, what can that data actually tell us? How can it help us? Is it really just for use in research situations, or are these things or any of these things we could actually eventually see in classrooms? Probably none of these things here, but eventually. Okay, so in 2017, my PhD student, Camilla Meshevik, and we did a State of the Field report on learning analytics. And although it's 3 years old, I would like to still show you a couple of the things we found out at that time. And that was that very early, we had 103 papers in the final data set that we had in this systematic review. And we found out that the majority of the papers were using log data. So 60 of the papers were using log data, and you can see that across the bottom. I'll show you that here. So here you can see that all those papers, 60 papers were using log data, but only 12 of those papers were doing it by itself. So only 12 of the 60 papers only used log data. And then if we look to see when they used log data, performance data, demographic data, pre and post test data, there was one paper. So you read this table by going across to see exactly how many papers were used doing different individual data sets, and then you see that the majority of them are combining them with other data. And some of them up to 5 different kinds of data sets. So you have a lot of problem in making this data, triangulating this data, or synchronizing data. If you're starting to get into sensors and things, you spend a lot of time on getting the data to be usable. And anyone knowing anything about big data analytics knows that about 85% of the time you use to get the data sets in good shape before you can actually then work on them for analysis. Okay, so now that we know what kind of data we use, what kind of learning analytics can we do? Again, from our same study, this one is showing that the majority of the work, the pink papers, is from universities. So up until 2017, the majority of the work was going on with universities. And I would say still probably there, but we're starting to see more in the primary, middle, and high schools, which you see to the left there in the green, orange, and the light blue. And then there was always a lot of work on MOOCs, which is the light green to the right, with workplace learning being in the yellow, and then university and workplace, or combining the different settings with university and formal learning and workplaces still. But still the majority of the work. And I have a suspicion that as new fields emerge, it's usually academics that can get access to the data for their own students that start to do work in the field, and then we expand out from there. Different kinds of methods that were being used from learning analytics. The majority of the papers use descriptive statistics or correlation analysis or regression analysis. And then we start to see that as we move up the table, people are using things like network analysis, clustering, visualizing, t-tests, natural language processing, and more into artificial neural networks, text mining, all the way up to neural nets and multimodal analytics. And I would say that this again is 2017. So I think the higher up in the table you come, the more things you'll see. For example, definitely multimodal analytics you'll see a lot more of. And what kind of things were people doing in the analytics? Well, we found that there were very many of them, over 60 of the papers were contributing an application of some sort. A lot of them were making models, so developing models or frameworks or algorithms. Some were developing tools, and some were working specifically on theory, and then some were doing a combination of these. And I think that's true of the literature still today. You'll see that people are working on some of these different aspects. So one thing I want to think about and ask already now is that when we've got this kind of data, can we actually use the data? And what I mean by that is that many of us are very bound by these privacy regulations about whether we're allowed to use personal data from people. And we distinguish often out sensitive data, which tends to go towards health data and things like that. Can we actually use those given the rules in the country where we're actually working? In Europe, we're within the confines of the GDPR, the General Data Protection Regulations. And that requires either consent or it needs to have some kind of obligation to do some kind of learning analytics. Like if you're a school and you're supposed to give good education to people, you can find that you can use the data without consent if it's related to your national laws as well. But you have to do the work to find out which laws enable you to use this kind of data. And this is usually for data if we're going outside of doing research. If we're doing research, you usually have some kind of ethics committee or something that allows you to do some of the data, usually through consent as well. But it's not just about the data, it's also about the algorithms. So the GDPR is built on the principle of privacy by design, where you have to think about using ethical use of the data and thinking about the privacy things from the beginning. It's not something you do after you start thinking about your algorithms. You start early on. And just like in artificial intelligence, where we have responsible AI and we have biases in algorithms, the same is true of learning analytics. We find the whole gambit of issues there as well. So if you're going to be developing a product for a school or anything in Europe, then you need to have a data protection impact analysis, or a DPA, and looking at the risks and the legal evaluation for whether you're allowed to use the data or not. So it gets to be very quite complicated. So now we'll give an example later from our study, how we have been working with this. And so it will be interesting for you to look in your country to see if there's any kind of momentum towards allowing learning analytics to be done. So I will tell you what's been going on in Norway. So we have a new digitalization strategy, and this one's for higher education and research. And we have an action plan. And in the digitalization strategy that's been developed during the last 3 years, they have managed to identify that learning analytics is part of teaching and learning, that it monitors teaching and learning, and that facilitates better research on teaching and learning. And the result has been that the Directorate for Higher Education and Research has put a proposal into a committee working with the new higher education law in Norway. And they've given them 2 alternatives that they should consider. And one is that learning analytics is a duty. It's an obligatory task of higher education institutes related to the quality work of the education that they're presenting to people. Or if they won't go as far as saying it's an obligatory task, they can say that it's a defined alternative, but it's not obligatory, but there is still a legal basis in the law to say that you can use student data in order to carry out learning analytics. And we probably won't make it into the law this year, but at least it's moving towards being there. The other thing we see at the school level is that there's a number of white papers that are coming from the government This one is on helping people get through school. So to make sure that we don't have people dropping out of high school and retaining people. And the interesting thing in this white paper is they refer to Camilla's and my systematic review that we did, that I've shown you some of the results from. And they're saying that learning analytics is important and it can be, sorry, it's good to do this, but they want to put down a task force first that's looking at pedagogical, legal, technological, and ethical issues using learning analytics and ownership of student data in schools. So who owns the student data? In the school municipality we work with, they say they own the student data, even though it's different vendors deliver different tools to the schools. The data is still owned by the school board because they're the ones responsible for the teaching. So we're going to have a task force in Norway that's going to be looking at that before we have learning analytics into our law, but at least you see these things happening. When it comes to ethical use of data, already in the LACE project that I mentioned earlier, they already had some nice work. They had developed, Hendrik Drasler and his colleagues had developed what they call the delicate checklist, which is taking you through different aspects you need to think about before you use the data: determination, explain, legitimate, involve, consent, anonymize, technical, and external issues to think about before you implement it. JISC, they have a code of practice for learning analytics, a literature review of ethical and legal issues. It's getting a little bit older, but I think they keep updating, at least on their websites, if you're interested to see how they're doing it in England. And there's starting to be some efforts towards having responsible learning analytics, just as in responsible artificial intelligence. There was a workshop at LAC arranged by Sareto Pargman from Stockholm University. And they had Rebecca Ferguson, who's one of the early workers in this area and quite inspiring speaker, talk about trustworthy learning analytics. And we're having another workshop at ICALT. If anyone's interested in that, will be in September if you're coming to the ICALT conference. So there's starting to be this real movement, and there has been from the beginning, I think, this reflection, at least on the ethical use of learning analytics. Another question I want to bring up is that I always ask as well, do you have the data that you need? Because lots of time we have the data that we can get access to, but not the data that we need to answer questions. So that's something good to always have in the background when you're thinking about learning analytics. So now we'll go into some examples. So here's an example from Kennedy and colleagues in University of Melbourne, and they were looking at data from the education of surgeons. And they have a simulation machine that has haptic input where you have a drill that you can actually feel like you're drilling into bones, and it's measuring things like the speed you've got it at, the angle you're holding it, the pressure you're pushing exactly. And you're using this and it's collecting all this data and giving you feedback and adapting the next thing you need to try. We actually have these for dentistry at my university. So I've tried one of these machines for drilling into teeth. And it's really amazing the amount of feeling that you're actually really drilling into something. So this is one kind of way to give in a simulation environment to use learning analytics to adapt the training to individual students. I'm going to show you an example from a MOOC platform that we have developed at my center. Mohammed Khalil and Gleb Belakrish have developed this, and it's focused on learning design and trying to help people working with open edX MOOCs to help them design their courses better. It's using activity data, survey data, and discussion forum data, and it's based on student consent. And here's a very quick typical type of learning analytics overview you would get in a dashboard that shows you really quickly. You can see where the activity levels of students are. You can hover over things and see that the event counts on a particular day. So on my left, probably your right, you can see event counts. On this particular day, there were 147 different users and they created 14,208 events. On a slower day, which would be marked in blue, you only had 7 students or 7 users and you had 311 events. So you get a very quick overview about when people are working. This is the type of sequence mining where you can look at how people move through the different materials or different things you have in your environment. So are people on a page reading some data and then they move to a quiz, or do they go to a poll, do they go to a video, etc.? And you can do the sequence mining and find out how people are maneuvering through the material. And maybe they're not going where you think they should be going or where you want them to go, and you can make some changes on that. This one is showing only a 2-level sequence, but you can have it up to as many sequences as you want. You can find, for example, a learning trajectory through the material. Here's very typical learning analytics, looking at when people have a lot of videos. Here you get an overview of the 18 different videos used in this data, in this MOOC that was developed. I forgot to say all the data has been anonymized. It's from a MOOC at Oslo Met University in Oslo in Norway. But here they have 18 videos in their course, and you very quickly can see which videos are used the most and which are used the least. So you have video 5 is not used very much. Why is that? Maybe you want to investigate why that is. And in video 4 and 12, you see it's used a lot. You can also hover over this and get more details based on these colors here. So you can find out how many times it was loaded and played and paused, stopped, speeded, etc. And the paused and where people stopped and where they seeked, maybe that can help you find particular, what are they actually looking at when they're doing these things? Where have they paused? Where have they stopped, etc. And you can click right on this data and get that up. And maybe you can look at the video and find out, okay, here seems to be a concept people are going back to, or they're stopping at, or whatever. It can help you try to understand the use of the videos that you prepared. And here, maybe you'll decide video 5, there's something really wrong with that video. Maybe we take it out of the correct curriculum. So then it's helping you with the design, the learning design of your course. That was an example of learning dashboards for instructors. You can also have learner-facing dashboards or for learners. And there's a really beautiful PhD by Iona Jivet, just came out this year, called The Dashboard That Loved Me, where she was looking at people who are designing dashboards and what kind of what the dashboards are supposed to be supporting in the students. So which competence in a learner are you trying to support? Are they metacognitive, cognitive, behavioral, emotional, or self-regulation? And if you're supporting those, what kind of impact are they having? So for instance, if you're really trying to support metacognitive aspects, you can help students on their awareness and reflection. If you're looking at cognitive, maybe you're helping them with their goal achievement or their performance in a course. If it's behavioral, maybe it's about their engagement or their social interactions or how they can seek help within a network of the course, for instance. Emotional, for their motivation, effect, and self-regulation. Maybe you're helping them with self-regulated learning and helping them to become more self-regulated. So there's many different goals that you can have with these kinds of dashboards. And I'll just show you 2. Here's one. It's from a European project. You can see the link there from the Krish project, where they're using, it's for language learning, and they're looking at competences. So they have a list of competences down here in the middle, and then they can show your progress towards the competences, where you've got the little hand showing the overview, where you've got green, you're doing good progress. And this is based on the CIFR framework for learning second languages. So it's based on a theoretical model about how you progress in learning. And you can compare yourself to the class average or the school average, and you can click on these things and find out where you've come to and how far you're coming in your learning. Here's a similar, and this one is looking at users' behavior analysis in the learning environment, progress towards the competences, which is this dashboard. It's using student information, test results, and tool use in order to come up with these scorings that you see here in the green or the orange or the red. Another example is from the University of California, San Francisco School of Medicine, where they're using student data and performance information from different assessments that medical students take. And it's very important for them to progress towards their learning goals and their exams that they take, etc. And this is a dashboard that they can look at to see how they're performing in the particular place in the curriculum they are, and they can find out how they're doing on the scores, etc. So this gives you more of a progress. It's not competence based, but it's based on how you're doing on the exams that you're your learning and the different checkpoints they have along the system. Here we have a very nice project. It was one of the first projects in Europe, at least, on multimodal learning analytics. I borrowed the picture from Daniel. We had a PhD course this year together, and there's the link to the, I forgot to correct it. It's www.pellers.eu, and you can find a lot of the publications there. But this was a very interesting project because in the previous projects or previous examples I've been showing you, they've been using learning trace data, but here they wanted to be able to understand what data to collect and how do you analyze it when it's not just online data, it's also how groups work together and how they move together and how they're, solving a problem here. And they wanted to understand collaboration in makerspaces. And this is a really good example of multimodal learning analytics and how you have to build different kinds of ways to collect data. And they were using things like computer vision, movement of people's heads and gesturing of their hands and all sorts of things, trying to understand in physical space how people are collaborating. And they were putting that data together with some of the digital data that's collected in doing it. So you can go and look at that project if you're interested in multimodal learning analytics. Here's another project that we did in my center. We were working with some firefighters that were doing training, and when firefighters go into a smoke-filled house while they're training, they have no idea what they're doing while they're in there. So we were looking at using mobile data, motion and time data, and positioning sensors to try to give them a visualization of how they were moving inside this house, where they stopped and where they looked around. So we were just using very simple positioning systems and checking the directions movement on the mobile data as well. Nowadays, there's much more different kinds of sensors we could use to help with this. But the idea here was to give the trainers an idea about, are they doing a good job while they're working in this house, and they can give them feedback at maybe you should have gone in a different way and behaved differently when they're inside this smoke-filled house. So the picture I have here is before the smoke was put into the house, just so we could have a nice picture. But usually you can't see anything. I'll also tell you another interesting project you can look at is Ken Holstein's project. He's in Philadelphia, and he's got these teachers wearing these LUMILO glasses. And with the glasses, they can look out over the classroom and they can see visualizations of what students are doing. So it's taking the activity data from the system that the students are playing with, learning with, and it's visualizing if they have a problem with a question mark or they're struggling with something. If they have their hand up and want some help, they have the question mark or the hand up. You can see that. If they're doing something they shouldn't be, you can see the little triangle over the little boy in the front. Then maybe a teacher wants to check what they're doing, and they see some other kinds of visualizations about how they're progressing towards different masteries of different practices, etc., what errors are coming up, etc. And just by having these glasses on, the teacher can see out over and get an idea how the students are doing. And it's hard in a big class when you don't know which student you should help, etc. And you can get some both individual student plus class level information. So I say you should go look at this project. It's really, really fun. Okay, and then now I'll just use about 5-10 minutes to tell you about a project that we're doing. So now we're moving into actually implementing. It's not a research project per se, driven by a research project. It's driven by a municipality in Oslo that wants to look at adaptive learning in schools. And we're the research partner on the project. So it's called Activity Data for Assessment and Adaptation. That's the translation from Norwegian, but it's okay. It's led by the project owner is the municipality, the Association for Municipalities in Norway called KOS. And the main idea in the project comes from the Municipality of Oslo, their Department of Education. And then, as I said, Slate is the research partner in here. And what their goal is to monitor student progress and recommend tasks for students to do. That's the overall goal, and I'll show you how we're working towards that. But it's a very interesting project in the fact that we're not working with data from just one tool. So the motivation here is that students use many different tools, and in these examples I'm going to be showing you they're from math. So we have many different math tools that students can use in their math learning in school or for homework as well. And Normally the teacher, to find out how they're doing in these tools, has to log on to each tool and look at each dashboard and figure out how each student's doing, etc. And if they're using many tools, they don't have the time to do that, and it's awkward. So the main idea in this project is that the activity data created about each student in each tool is collected into a central learning management system. We ask for the data in the international XAPI standard for activity data. So we get all that data into the LRS, and we've developed a central tool called Mitt Fagkart, which can then pull the data together, analyze it, and make dashboards for students and for teachers. And I'm going to show you the teacher dashboards today. So that's the general idea behind the project. The point is that we get this data from across tools, and it's very different formats in each of them, but so we ask them to put it into XAPI standards. We're not going blind into this. We've done extensive work with teachers, finding out when students are using these different kinds of tools, what do you want to know about your students? So they want to know information at the individual student level, at group level, or at class level. So they don't want just about individuals. They also want aggregated data across all the students. They want to know what discipline topics, what topics in mathematics are the students struggling with, or what have they been working with, or how are they progressing? They also want to know about the competence goals and how they're progressing towards competence goals, because in Norway, our national curriculum is based on competences, and I'll show you that in a moment. And that complements the discipline topics. They want to know what exercises have they been working on. Are there different kinds of exercises they're having trouble with? Are they having trouble with multiple choices? Are they having trouble when they've got a visualization? Are they having trouble when it's a video they have to read and interpret, etc.? They want to know what competence gaps an individual student has, but also the class has. Where is it that the class really needs to have some help? And what next? What should I be telling the students to do next? And you can think this and turn this around for individual students as well. But in what I'm showing you here, I'm showing you the teacher side of it. So here we've designed a Mitt Fagkart dashboard, and the students and teachers can log in through our national authorization system called FADA. And that makes things really, really nice for us, because in Norway, if you're delivering educational tool to schools, you have to have the authorization for people to log into it through FADA. So we have an idea about we know who's doing what in the system because they've logged in through this standard authorization. So this makes it possible to get the data for one student from many different tools. And then on the back end, we have a learner model. So if you remember when I showed you Bajankowski's way to look at learning analytics from the beginning, where they had some kind of student data inside of the learning environment, we are creating that learner model from across all these tools. And then we've got analysis and recommender algorithms that are going to work on this particular data. Everything's not finished, I'll just tell you that now, but this is how we're moving. So to take a step back and explain how we can actually make this work, it's because in Norway, we have a national curriculum based on competence goals, as I said. So, and all the EdTech vendors have to tag the items in their tools to the competence goals. And one competence goals could be something like explore and explain the relationship between a fraction, decimal, and percent, and use these in mental arithmetic. Now, if you're a teacher and you're getting that competence goal, that's very big. You can have lots of different things you could do within that goal and many different kinds of items you could work on, etc. You could compare a fraction and a decimal, or a decimal and a percent, or you could do all three of them, etc. So when you're a vendor and you're making a product, or you've got a tool task, let's say you have a task where you're going to compare a fraction and a decimal, it would be really nice to know that that's working on a fraction and a decimal and not just this level of competence goal. So we've had to make what we call the Fagkart, or a domain model. Those of you from intelligent tutoring systems or adaptive learning environments know that you often have a Fagkart or a domain model that maps out the main concepts within a domain. Sometimes it has relationships between them, sometimes it doesn't. So we have taken all of the competence goals for math from 1st to grade 13, which we have in Norway, and we've taken all the concepts out of them and made a domain model that we're using. And so we ask them to not only tag to the competence goals, but to tag to the domain model as well. The other thing that comes in Norway with the curriculum is they have a number of what they call key items or key elements of it. And those are things like being able to do argumentation, being able to do like higher order skills that you can have. And then we have something called grundleggende ferdigheter, or the key issues, and those have to do with reading, writing, speaking, arithmetic, and digital skills. And each of the competence goals is also coded in a national database, so it's all digital with these key skills and the main elements like argumentation or making representations and different things like that. So we have a lot of data that's accessible to us when we're building applications that's already tied specifically to the competence goals, which makes it possible to do that. So here's our mathematics here. And when we do is we ask the vendors to tag to this domain model, and right down to the level that we break it down to, for example, the different verbs like to make or explain some concepts, etc. And by doing that, we get much more fine-grained analytics that we can do. Then we allow them to publish. We use this tagging tool that we've made for them, and then they can publish it, and they get a link that gives them a link to a set of JSON code that describes the code for the tagging that they've done. And in the XAPI statement, they just embed this tag to us, and we can get, because we have a database of these tags, and we can get the detailed information. Here's some examples of different visualizations we have. This is from a master's thesis, my student Maria. We can do visualizations of their progress to the competence goals, and we can do different kinds of visualizations for example, the topics within the knowledge areas. Within mathematics, you can do a tree, a typical concept map tree, or you can do a circle tree to give the colors and the sizes, meaning how much they've been working on it. And when we have those kinds of visualizations, then of course you can have algorithms that are also looking to find out where have they not been working, where do they seem to have trouble, what are they doing right and wrong, etc. And then we have this verbs, because the teachers really wanted to know, are they having trouble argumenting, are they having trouble comparing, or are they having, where are they working, what are they doing, etc. So this gives the teacher very quick overview of what they're doing. We can also show how much individual tools are being used, and I've put out the tools that have been used here. Then finally, the thing about this system that we're developing, it has taken off, and the ministry and the Directorate for Education have gotten very interested in what we're doing, because we're starting to move towards an ecosystem for allowing learning analytics in the school sector. So we have this national tool. This is what I've described to you, so that the students and the teacher can log in through FADA. And then we have on the right, we have that they use a vendor tool, which is called Lardawerk here. There's everything stored in the learning record store. And then it's into Mitt Fagkart, our tool. In addition, we have this tagging tool that we have developed to allow them to tag to this. And this tool can be used for anything other. Mitt Fagkart is just one application. So we're using it in another project we have as well. So that's also reusable. They've also made a planning tool at the Directorate for teachers to make plans, which also can give us information about how to narrow down what we present to teachers. And they've made a search for they have a search tool that they're working on, the national international standard for doing searches of open educational resources. And each of the items within a vendor's tool could be recorded in this search as well. So we're going to test out doing searches for when we're doing a recommendation of what a student should do next. We're going to be able to use this search to try to find items that they could do. And this is, we're doing a new modeling for payments in Norway, for educational tools in schools, where I call it Spotify model, because it's based on the use. So we use the activity data from students using tools, goes into a tool that's been developed that counts up how many students have been using a tool during a month period, and the vendors are paid based on that. Instead of having to have a school buy a really expensive license to one or two tools, they can have access to all the tools that are available within a school municipality, and they can pay based on that. And this is being very, very interesting. The vendors are not, they're sort of unsure about it. The school municipalities love it. So that's something else that's going on. Okay, so just in my last summary about implementing learning analytics. So one thing you always have to think about when you're actually working, not in a research project, but out there implementing things, who owns the data? You need to have a legal basis for allowing data use, consent or obligation. Are you giving, and one thing that I've learned as well is that if the output of your algorithms is a recommendation, or if it's an automatic aspect coming out of, so if your algorithm has something that's used, the output of it is used automatically for something, there's very different legal basis for that. In Europe, at least, you have to do this DIPA, and in Norway, my experience is that they bring in all stakeholders of products, for example, parents and teachers, school owners, etc., to be part of this risk analysis that you have to do. And you have to have data handling agreements for the people who own the data. And I've also learned that there's no such thing as anonymous data at all based on the legal GDPR data. So as long as the original data that is existing still from, if you have original data that you've then anonymized, as long as that original data is not deleted and gone, you cannot have anything that's really considered anonymous or even pseudo-anonymous. We have to think about, do you have the right data? I mentioned this before. The data that you get usually is you're at the mercy of the learner tool developers that are giving you the digital data, or unless you're able to design your own data collection. So you have to think about that. Can you actually access the data? So for us, we've had these issues. Are we going to get the data in real time, which is one other challenge, or are we going to get it on a scheduled time? And so, for example, we want to get it real time, then we have to ask the vendors to implement an API for us to access. That's also not necessarily that easy. The quality of the data that we have, do we have the data in the right format? In our case, we're talking about tagging the data so that we have it in X and then putting it into XAPI format that we can have this interoperability of data across the different tools. But we also have to think about how do we deal with missing data and how, if our data is not super good quality, which I guarantee you it's not going to be. There's always challenges with having good data. The analysis of the data, is the data, again, is it in the right format? It's the same issue. Do you have a standard for the data that you can then, analyze the data across the different data sets that you're getting? And what about the certainty in your analysis? Are there legal repercussions based on the decisions that your algorithms are making, etc., or your analytics are making? And finally, the requirement for explainability. What data and algorithms? How can you explain what's going on? Because within the GDPR, they have the right to know what data you've got and what your algorithms are doing with it. And in our particular project, we're lucky enough that our National Data Protection Agency is currently running a sandbox for artificial intelligence and learning analytics we've gotten in. And we're participating in this sandbox together with the National Data Protection Agency to go through our application and look 10 years ahead where we could possibly be when we actually have really good data and can do machine learning on our data sets. We don't have enough data and we don't have good enough data yet that we can do that. So we're doing more statistical analysis at the moment. But we need to look at the legal basis for handling it. We're doing our data risk analysis. We're having a session on transparency and explainability because I want to know, what do I really have to explain to a child about an algorithm that's deciding what they can do and what they can't do, etc. And how do we communicate this? So we do this together as a project and with a large group from the Data Protection Agency, and they picked out 4 projects only that got to be on this, and we're the only one from the school sector that's involved. There's several from the health sector and one from data security sector. So that's really interesting and challenging and very much work. So in summary, in learning analytics, we're very based on data. You have to think, do you have access to it? Who owns it? And do you have privacy issues with the particular data you're trying to work? Privacy and data protection, probably should say. When you're picking up data, there's always a context. And data and an algorithm that you create in one context probably cannot be used in another context, most likely can't be. So you have to think about the context in which your data has been taken up. And that's another type of data is the context of the data you've got. Is it explainability about the algorithms and the data you're using? And to remember that we don't reduce people to just their data. It's only one little tiny picture of what it means to be learning something is this data that we have. Scalability, issues around interoperability, the use of standards and algorithmic transfer. So if you make a prediction algorithm in one institution about who's going to drop out, I can guarantee you, you can't use it in another institution. So you have to redo these. You can get ideas from each other, but you really have to build the algorithms from the bottom usually. And impact, once we do the analytics, is it actually usable? Can people use the results of it? Are our dashboards usable? Can people understand what we're showing them? Can they understand the feedback we're giving or decisions we're recommending? Are they actually used? So you can make these beautiful dashboards. Maybe they can understand them in your studies, but do they actually use them? Why don't they? Why are they not used? Maybe it's too much information. Maybe they don't have the time, etc. You need to check all these things. And can we show impact on learning outcomes? Because that's our ultimate goal, is to help people learn better. And what kind of outcomes is it that you're looking for? You know, are they having a deeper understanding of topics, or are they coming quicker to the end of it, etc. There's many, many different things you can look at. And then to always remember the ethics, the privacy, and the morality aspects to the data we're using. And I always like to use this slide at the very, very end. I've taken it from Paul Kirchner, who had the keynote at LAC in 2016, and he reminded us that, and this is about the data and about learning analytics, is that the data that we get is the data we can see. And sometimes the most interesting data is outside of this area. So be conscious of the fact that the data that you have is only a very, very small part of what you're looking at about a learner and about their learning. And then you can do some nice analytics. Okay, thank you.